Now with the composition is the domain is much like when you're doing the division, but here you have to stop once again before you do any of the simplification. So if you have F composed with G, so that means that this is the same as F receiving as an input function G of X. So F will take in 1 over X. So if you use a different color for that 1 over X, that is your G of X, that's your input. So every time you see an X, you're gonna substitute that by the input. So we're gonna have the input over there, the input here, and then you're gonna add a 2. So this is gonna be 1 over X and 1 over X. Before we simplify any further, you have to once again locate your denominators. So you have numerator by denominator, you have numerator by denominator, and once again, numerator by denominator. So all denominators are gonna be different than 0. So this denominator has to be different than 0, this denominator different than 0, and the big denominator 1 over X plus 2 has to be different than 0. So here we already have our first restriction, that's 0. The second one is gonna be 1 over X has to be different than minus 2. So 1 has to be different than minus 2X, and you're gonna end up with X different than minus 1/2. So what values are we going to exclude from the domain? That is minus 1/2 and 0, either of the 0. So the domain is gonna go from minus infinity to minus 1/2, then from minus 1/2 to 0, and from 0 to infinity. And now you can proceed to rewrite your final answer. And I'm gonna do it down here. So if you have 1 over X divided by 1 over X plus 2, if you remember, a fraction will remain the same if you multiply it by 1. So if I multiply that whole fraction times 1, I'm not altering the result in any way, because anything multiplied by 1, it will be equal to the value that you had originally. So as long as that value I multiply by is still a 1, everything will remain unchanged. So if I multiply by X, I'm altering things. But if I multiply by X divided by X, I'm not doing anything, because this is a 1 disguised as X over X. And if I leave it like that, I'm going to multiply X by that whole thing and X by this whole thing. So I'm going to end up with 1 times X. And this is like having X divided by 1 and X divided by 1 if you feel more comfortable. So divided by X times 1. And here we're going to end up with, if you multiply X by the first term, it is going to be X over X plus 2. But that 2 is also being multiplied by X. So we have to multiply by both terms. So this is going to end up as X over X, that's 1, divided by X over X, once again 1, plus 2X. So your final answer is not going to look as messy as we had it there. It's going to be 1 over 1 plus 2X, or 1 over 2X plus 1. And that's pretty much it. Now, we're doing another composition. We're doing h composed with s, meaning that we're doing function s taking the function h taking s as an input. Let's go ahead and do that. So h is taking function s as the input. So let's have a look at those. Because we have a square root function to take h will take an input of s of x. So that's the same as saying that h will take an input of whatever s of x is, so x minus 3. And that means that we're going to write the square root function, and every time you see an x, you're going to plug the new input. In this case, the new input is x minus 3. And let's go for it. We're going to do the multiplication first. So 2 times x, that's 2x, 2 times minus 3, that's minus 6, and then plus 16. This will turn into the square root of 2x plus 10. Now, that would be our answer here, square root of 2x plus 10. But the domain, remember, the domain is not about, the domain of a square root is not about getting 0. It's about trying to avoid negative numbers inside of the radical expression. So we're going to say that 2x plus 10. How do we tell that expression not to become negative or to be always a non-negative value? Well, non-negative values are greater than or equal to 0. As long as this is always greater than or equal to 0, even 0 will be a good option for us. So that's going to be 2x has to be greater than or equal to minus 10, and x has to be greater than or equal to minus 10 over 2, getting us x greater than or equal to minus 5. So that would be the restriction, or we can say that it's going to go from minus 5 and everything that's greater than minus 5. So that's moving to plus infinity. Infinity is something that cannot be reached, but the minus 5 actually has to be included because that would produce a 0, and square root of 0 is still 0. Now, what happens if you do g composed with f? So you don't have to do much because we're evaluating this with 1. So you can do the composition or you can do just the evaluation. If you're doing the evaluation directly, it would go something like this. So you're saying that g is taking f with a 1 already as the input. So if I use 1 as an input on f, you're going to have, let's go for that. F of 1 is going to end up as 1 divided by 1 plus 2. So I'm using 1 as an input on this function. So that's 1 over 3. So if f of 1 is 1/3, that means that g of 1/3 is the final evaluation. So basically this function now is taking 1/3 as an input. So that is 1 divided by 1/3. So that's basically having 1 times 3 and 1 times 1. It would be 3.